Okay, this is a word problem with sum to infinity. It's quite a popular one, or variations of this bouncing ball phenomenon are quite popular, shall I say. And it requires quite a bit of thinking. It's a nice question, very much a problem solver. Okay, a bouncing ball falls from a height of 1 meter and bounces back to a height of 9/10 of a meter. I just want to draw some pictures here because I feel like that's really going to help. So here's the ball. It falls from a height of 1 meter. We're going to assume it falls straight, okay, down. So that's 1 meter. And then bounces back to a height of 9/10. So when it goes back up again, I know this would be all in the same space, but I'm just going to put like the lengths together. So it's going to go up to 9/10 of a meter. So that's 9/10. So that's the distance it travels, and it goes back up. Okay. Then it's going to go back down again. This time it's going to go down from this height, yeah, down another 9/10, right? Because it starts off here, goes down, goes up, goes down again, and falls again. So it falls again, so the 9/10 is done again, and again bounces back to a height of 9/10 of the previous height. Okay, I really want to know what that is. 9/10 of 9/10, right? So just a quick calculation on the side here. 9/10 of 9/10. Let me just write that as 9/10 squared. And there's a reason for writing it like that and not making it 81/100. So it goes down, goes up 9/10, goes down 9/10, goes up 9/10 squared, and then goes down 9/10 squared. Then it's going to go up 9/10. Can you see it? To the power of 3, and it's going to go down 9/10 to the power of 3. Okay, I'm making these all look the same, but you know what's happening. So in terms of its distance that it's traveling first 1, then 2 of 9/10, then 2 of the 9/10 squared, then 2 of the 9/10 to the 3, then it'll be 2 of the 9/10 to the 4. I'm going to put that into just a little series of things, and then we're going to decide what to do with it from there. 1, okay, then there's 2 of the 9/10, then there's 2 of the 9/10 squared, plus 2 of the 9/10 to the 3, plus 2 of the 9/10 to the n, basically, but n is infinity, so yeah. This does not look like a geometric series, but it sort of half looks like it. So what about if we know that it's 1 plus this? Isn't this a geometric series? Doesn't that look like it should be 1? Yeah. And let's leave out the 1, and let's do this thing separately. So I'm going to rewrite this as 1 plus, and then this whole thing can be my geometric series. And then I can just add the 1 back at the end, just to sort of keep myself sane here. Okay, just checking, is it a geometric series? If I take that divided by that, perhaps you can see it in your head, that divided by that, the 2's will cancel and the square will cancel, so I'll end up with 9/10. If I take this one over that one, I'm going to end up with 9/10. So yes, it fits the criteria. It is in fact a geometric series. Okay, so this whole thing is going to be inside as my geometric series. So I'm just trying to, by the way, this is 2 times 9/10. So it's not 2 and 9/10. Otherwise I wouldn't put brackets there. Okay, plus I'm just going to do that for myself. Okay, and then I'm just going to quickly work out A and R. Why? Because I want the total distance, so all of these added, traveled, if the ball bounces indefinitely. So I'm definitely doing sum to infinity here. Okay, so what's my A and my R? Because I left out this on purpose. Okay, so I'm not going to have A as 1. I'm going to have A as 2 times my 9/10. Then my R, we already worked out, is the 9/10. So when I go sum to infinity, I'm going to say sum to infinity equals a over 1 minus r. It equals 2 times the 9/10 over 1 minus 9/10. And when I plug that into my calculator, I get out 18. What was my unit again? It was a bouncing ball falls from height of 1 meter. Okay, so if this thing bounces forever, weirdly enough, it will only ever cover 18 meters. That part of it, remember what I did? I separated it out. This part, this bit with the 2's gets you to 18 meters. So what we must remember at the end of it is to say 18 plus 1, and I get 19 meters, and that, because of the plus 1 there, that is my actual answer.